Okay, good afternoon. So let us start today's lesson. Today's lesson, actually the first chapter is more or less review and completion, but of course from the next chapter everything will be new. The first thing is, in the book if you see it, is the topic of polynomials. You already know what a polynomial is in principle. But let us just review this a little bit. So a polynomial is actually an algebraic expression. An algebraic expression is an expression which involves variables in it, yes? So if I write, for example, x, if I write x plus y, I don't know, if I write x squared plus 2x plus z cubed. These are all algebraic expressions. The square root of x plus 2, x minus 5 divided by x to the power of 2 plus 3x minus 5. So these are all algebraic expressions, yes? Algebraic. So every letter that appears in an algebraic expression is called a variable of that expression. So this is probably the simplest algebraic expression. Of course, numbers are also algebraic expressions. It is good to add a number here in our list as well. For example, 5/2 is a number. That's also an algebraic expression. But it's a constant algebraic expression. But these are algebraic expressions with variable or variables in it. So here I have only one variable x. What do I mean by a variable? It means that it represents a number, but exactly which number we don't know. We can assign any number in its domain to the value. That's the meaning of being a variable. So here when I talk about 5/2, it's completely clear what I'm talking about. But when I say x, even though I am presuming that x is a number at the end, but which number it is not clear until I myself assign an exact value, a precise value to it. That's the difference between a constant number and a variable. So here I have again an algebraic expression, but this time it contains two variables. Yes, one of them is x and the other one is y. So again, this algebraic expression cannot be fully specified unless I give you one value for x and one value for y. Then it becomes a number again at the end. So this is why you shouldn't feel strange. Because when you are in primary school learning about English language, you know that x and y are letters in an alphabet, yes? So we don't add letters in languages, yes? So, but we are adding x plus y. So this should be in principle a little bit strange. But the convention is that x and y are variables representing numbers, and addition for numbers is defined, so x plus y is also defined. If I assign one value for x and one value for y, yes? So you shouldn't be worried about calculations that you can do with numbers. You can also do with letters, because we are assuming that letters are representative of numbers. That's it. So in this expression, that's completely understandable. So this is also an expression in two variables. So when I say x squared, I mean that I multiply the number which is assigned to x by then that number itself, producing x squared, because a number squared means that number multiplied by itself. I can also, for example, again, this is in two variables, but if I add, for example, y to the power of 3 here, then I will have an algebraic expression in three variables. So you can have any number of variables in an algebraic expression that you desire. Okay, so that is also an algebraic expression. That's also an algebraic expression. But not all of them can be called a polynomial. So a polynomial is a particular form of an algebraic expression. So there are some restrictions that you have to respect in order to have a polynomial. And that is it. If you are supposed to have a polynomial, the exponents that appear for the letters should be 0, 1, 2, 3, etc. So they should be in this list. So the powers should be in this list: 0, 1, 2, 3, 4, and etc. So you are not allowed to have something except these numbers as an exponent. For example, in that case, you can consider 5 over 2. Let us talk about x itself. Is x a polynomial? I would say yes, because first of all, it is an algebraic expression. Secondly, what is the exponent? What is the power of x here? 1. And 1 is in this list. So yes, that is a polynomial. Yes. What about x plus y? The powers that appear here are 1 and 1. Both of them are coming from this list. So that's also a polynomial. It's a polynomial with 2 variables. It's a polynomial in 1 variable. Is this also a polynomial? Yes, because you see the powers that you see here are actually coming from this list. So that's also a polynomial, but a polynomial in 3 variables. So what about this one? Is this a polynomial? No, because another way of writing this is what? X plus 2 to the power of 1/2, and 1/2 is not in this list. So that's not a polynomial, even though it's an algebraic expression. So what about this one? Is this a polynomial? So let me talk about this one, which is easier first. Do you think 1 over x is a polynomial? Yes or no? No, it's not a polynomial, yes, because if it is x to the power of -1, and -1 is not in that list. Okay, so I just want you to understand exactly what I mean when I refer to a polynomial. So 1 over x is not a polynomial. It's not one single polynomial. It's a division of 2 polynomials. If you say the numerator is a polynomial, I agree with you. If you say the denominator is a polynomial, I agree with you. But if I divide 2 polynomials, it is not necessarily another polynomial. The simplest scenario is this one. If you ask me 1, yes, it is a polynomial. X is also a polynomial, but 1 over x can be written as x to power -1. -1 is not in this list, so it's not a polynomial. But by the way, why is 5 over 2 a polynomial? Yes or no? Because 5 over 2, any constant number can be written as 5 over 2 x to power, for example, 0. Or you can write it as 5 over 2 y to power 0, or you can choose any letter that you want to. So if I ask what the variable is, there are no variables, because you can choose x, y, or any other variable. But one thing is clear, it's a polynomial because when you write it in that form, the exponent that appears is in this list again. So this is why every constant number is also assumed to be a polynomial. Yes? In this lesson, in our lesson, we are not dealing with polynomials with more than one variable. So even though this is a polynomial, we are not going to work with these polynomials that much. We are only considering polynomials in one variable, and usually we choose letter x for the variable.
So yes. A number like 1 over 10 is a polynomial too?
Yeah, in that case, yes, because 1 over 10 can be written as 1 over 10 x to power 0. So that's also what polynomial. Yes? Yeah, constant numbers are all polynomials. I will talk about the degree 0. So what if I want to get a better definition? It's a little bit ambiguity. I understand what you mean, because you can say that I can write 1 over 10 to the power of -1. So why don't you say that's a polynomial? Because the precise definition of a polynomial in one variable is this. I would say that a polynomial is some kind of function of x, and usually we use letter P for polynomials, F and G for functions. And this is something like this. Let me write it for you first. A polynomial is an expression of this form. An expression can be rewritten in this form, in which a sub n minus 1 up to a2, a1, and a0 are real numbers. Do you remember this symbol? This means belongs to. And this is the set of all real numbers. An expression that can be written in this form, in which these are real numbers, and n belongs, so n is 0. So let me say n belongs to this set, the set of 0, 1, 2, 3, etc. This is a collection of numbers that I wrote here. I put them in curly brackets because this is the standard way of denoting a set in mathematics. And I then can write n belongs to this collection, to this set. If you have an expression, an algebraic expression of this form, with these two conditions, then it is called a polynomial in X, or a polynomial in variable X. So these are numbers. So I could use some simple letters A, B, C, but because I have many of them, it is not very efficient to write A, B, C, D. How many terms I can group? Yes. So this is why instead of changing the name of the letter, I am equipping them with an index, a subscript, to denote different numbers. So this is called A sub n is a number, A sub n minus 1 is another number, A sub 2, A1 sub 1, and A0. This number at the very end, which does not contain the variable in it, the variable is x, this does not contain the variable, this is called the constant term. Okay? And these numbers that appear next to x are called coefficients. So technically, when you write a polynomial, coefficients are coming from the set of real numbers, and the power that appears here should be in this list, all of them. And the highest value, by the way, has a name, and that is called the degree of the polynomial. Remember, you have to call it degree, not order. So this is the degree of p of x. And you usually denote it by this symbol. DEG means degree of p of x. And say that degree of px in this case is n. So if I ask you what is the English definition of degree of a polynomial, you will tell me that the highest exponent that appear in a polynomial is called its degree. Okay, so let me make it very simple for you. For example, one scenario is that p of x is equal, let me write the first one, x here. So probably this is the very simple polynomial that we have. So if you look here, how many terms do we have in this case? How many terms do we have? Only one term. What is the highest exponent that appears is 1. So I can say that the degree of p of x is 1. So this is a first degree polynomial, x to the power of 1. And then in this case, if I ask you what is a node in this case, what is a node, by the way, in this case? What is the constant term? What is that? The constant term is that term which does not contain x. There is only one term and it contains x. So there are no constant terms. So it means the constant term is 0. Okay, and then in this case, this coefficient is a1, which is 1. That's it. So this is my polynomial of degree 1. The constant term is 0, and the highest, so the coefficient of the highest degree is 1. I can give you another example. For example, q of x, I can write 5x to the power of 3 plus 2x minus 1. Okay, is this a polynomial? The answer is yes, because the exponents that appear here are 0 and 1 and 3. All of them are in this list. So that's a polynomial. How many variables are there? One variable. The name of the variable in this case is x. If I ask you what is the degree of this polynomial that I have written, so what is your answer? What is the degree? What is the degree? Yes?
Third.
It is 3, yes. It is of third degree, yes. It's degree 3. So then if I ask you what is the constant term, I can just symbolize it by this. The constant term in this case is what? Minus 1. So you should include the sign as well. And then the next one is what? A1 is 2. Yes? But can you tell me what is A2 in this case? What is A2? Because you see, the power was 1 here. You expect to have a power 2, but it does not appear. So it means that its coefficient is how much? Is what? 0. So A2 is 0. And then what is A3? What is A3? 5. So you see that's the meaning. So by the way, if I want to write a polynomial, for example, if you are coding, if you want to write a code and you want to introduce a polynomial to a computer, you really don't need to write it in that way. You can give an array of numbers. So an array of numbers can be viewed as a polynomial if you have a good definition before that, yes? Is that clear? So any polynomial of degree 3 is connected to not 3 numbers, is connected to how many numbers? 4 numbers, so 1 more, yes? What about this one? If I write r of x is equal, by the way, I have seen in national exam questions, they write a bunch of algebraic expressions and they ask you to check it out, which one is a polynomial. You need to check out which one is that, and that is one question. So r of x is 5x to the power of 3 minus 2x to the power of 1/2 plus 5. Do you think that this is a polynomial? No. Why? Because a power appears which is not allowed. So that's a very simple question, and you see some exercises in the book of this type. Yeah, is that clear? Okay, so that is the definition of a polynomial. A polynomial is an expression that you can write it in general in this form. There are some terminologies that you need to know. The highest power that appears, that number is called a degree. And the number that if appears without the variable is called the constant term. And these numbers that appear are coefficients. For example, you can expect to have a polynomial of this form. So let me write, for example, L of x. I can have a square root of 2 x to the power of 5 minus 3 over 2 x to the power of 2 plus square root of 2 plus the square root of 2, and then I have x minus the third root of 4. Is this also a polynomial?
Yes.
That's also a polynomial. It's a little bit a strange one, but that's a polynomial, because what matters is actually these exponents. So here I have 5, here I have 2, here I have 1, and of course here I have 0. And all those numbers are coming from this list. What are the coefficients? The coefficients are these numbers. Here is the square root of 2, here is minus 3 over 2, here is this square root of 2 plus the square root of 2. And if I ask you what is the constant term, the constant term is minus the third root of 4. Yes? By the way, sometimes people call this term the leading term. It's good to know. And usually I myself prefer to be a little bit organized, to write them in descending order of powers. This is called the standard form, but there is no reason to stick to it unless, for example, here, if I write 2x plus minus 1 plus 5x cubed, what I have written here is exactly identical to what I have here in different order. But I myself, and mostly in the books, they prefer to write it in that way. This is called the standard form. Standard form means that you arrange the terms in a way that the powers are getting smaller and smaller. So this is not the standard form, because the power here is 1, it goes to 0, it decreases, and then increases to 3. So that's not an ordered one. So these are the things that you need to know about the polynomials at this level. Any questions so far? Okay, sometimes they ask you different questions. For example, they can give you a polynomial, p of x equals to 5x to the power of 3 minus 2x plus 1. And then they can ask you to calculate this polynomial for these given numbers. For example, they can ask you, what is the value of p of 0? If they ask you this question, what does it mean? It's like a function. It means that replace every appearance of x with the number given. So this means that you have to go and replace every x that appears with that given number, yes? And this is just a simple arithmetic, yes? And then if you calculate 0, 0, 1, so the answer simply becomes 1. Okay, they can ask you what is, for example, p of minus 2. And what does it mean? It means that I have to replace every appearance of x with this negative 2. And then I start calculating. So it's minus 8 times that's minus 40 plus 4 plus 1. It's minus 35. So calculating a polynomial for given values of the variable is an easy task. It's just an arithmetic problem, yes? Okay, let me solve some problems from the book. So let me solve some level 2 problems. In this case, we don't have any level 3 problems because that's so simple. This problem is given to you, but it is not related to poly. So let me ask you in this. So this is question 1111 in the book, page 10. So here, something like this is given to you. F of x is equal to, let me ask you again. So this is some review. Do you think f of x is a polynomial in this case? Is it?
No.
No, it's a division of two polynomials, but it itself cannot be written in that form. Yes? So what can you do? At most, you can write something like this. If you want to bring the whole combination up, it is possible, but then you have to write a minus 1 for all of it. And there is no way to expand that so that it becomes a polynomial like that. So anyway, this is not a polynomial itself. And they have asked you 3 questions, f of 0 and b f of minus 1. And then another question, they have asked it in that way. For what value of x, f of x is 0? So we want to answer these 3 questions, which is extremely, I would say, simple. Okay, so this is a function, but this function in this case is not a polynomial. You want to calculate f of 0. The rule is the same. So you have to go to your function, replace every appearance of x in the function with the given variable, and then do some arithmetics to calculate. So it's extremely simple, yes? So f of 0, it means that I go here and replace x with 0. And then calculate. So this becomes 2, 1, the answer is 2. So the answer to this problem is a level 2 problem in this case, extremely simple. Okay, so this is part A. Part B, f of minus 1, I will do the same thing, but this time I have to replace every x with minus 1. So this becomes 2 plus, instead of x I put minus 1, and then I have 1 plus minus 1 squared. In the numerator, 2 plus minus 1 is 1, and the denominator minus 1 squared is positive 1, positive 1, positive 1 is positive 2. It's 1/2. Okay, I want to wait for you now. Can you tell me how to solve the last part? Because they are extremely simple, these. Yes, Afsh?
You can take the equation that we have and maybe equal to 0.
Okay, so you are right. So when you want, so x, we are looking for x so that f of x is 0. But f of x is given directly to you here in the problem. F of x is this combination. So this means that 2 plus x over 1 plus x squared is supposed to be 0. Okay, then what? Now what? Tell me what to do now. It's a fraction. A fraction, the numerator is 2 plus x, the denominator is 1 plus x squared. I want to force this fraction to become 0. So what should I do?
You can multiply both sides with 1 plus x.
Yeah, that is one way, which gives rise. This is completely correct. But when a fraction is 0, that's correct what you said. But when a fraction is 0,
Can't you just make
the numerator is 0. So yeah. So a fraction, remember, a fraction becomes 0 if and only if its numerator becomes 0, which is exactly the result if I multiply everything, as you said, by 1 plus x squared. But it is better to do something fast. I want you to understand it, but little by little it is good to do things fast. Okay, so 2 plus x is 0, and then everyone knows what x is. What is x? It's minus 2. Okay, let me change the problem a little bit. If I give you f of x equals to 2 plus x, and then I give you 4 minus x squared, and I ask you the same question. Okay, I ask you the same question. What is x so that f of x becomes 0? How do you answer this question then? Let us do the same. Yes, so you would say that f of x is equal to 0, and this means that the numerator, so this 2 plus x over 4 minus x squared is equal to 0. Then if you conclude that 2 plus x is equal to 0, and then you conclude that x is equal to negative 2. Are you happy?
No,
No. Why not?
because that's undefined. It just becomes.
Yeah, exactly. So I was a little bit careless when I said if you see a fraction, I said it is equal to 0, and I mistakenly used the phrase if and only if the numerator is 0. So if I want to make it precise, can you complete me? Can you correct me? Yes? So a fraction is 0 if and only if?
The denominator can be 0.
If and only if the numerator is 0 and the denominator is not 0. So if you want to state it, and that is mathematics, so you have to be 100% precise. So you see, this answer is wrong. Because if you say x equals to minus 2, if minus 2 is the one that I am looking for, it means that when you go and replace x with minus 2, the answer becomes 0. But let us check. If I replace x with minus 2, what happens? The numerator becomes 0. The denominator also becomes 0. But as soon as you see the 0 in the denominator, this expression is not defined at all. So I cannot say 0 over 0 is equal to 0. This is wrong. Yes? So this is why. Now how do you answer the question? Remember, you cannot say the problem is wrong. Because what was my question? My question is, find the value for x for which f of x is 0. You did some calculation. Now I am waiting for your answer. What is your answer? Yes?
There is no x.
There is no such an x. And that is not, this doesn't mean the problem is wrong. Yes? Do you understand this? There is nothing to be wrong or right. I'm asking you so when I say find x, implicitly I mean if possible find that x. So you should say no, it is not possible to find that x because there are no such an x. Yes? So that is important to understand. So not acceptable. Okay. This is one question in the book, and you see it is level 2. It's extremely simple. Let me solve one more, and then probably I should give you a little bit more time this year to practice on your own. And it's extremely important to solve as many problems as you can. Okay, because of the national exam. You have to keep everything in your mind until the end of the year. So that's important, yes? And then it doesn't happen if you practice quite a lot. Okay, so another question which also is a good excuse to review something from Math 2C. Let us see how many of you remember. Another question, I will solve one part of it probably, okay? So, question number 11, 12, the same page, page 10. The question is, for which value of x, what is f of x is equal to g of x? I just solved the last part, okay? The last part, part B, f of x is given to be 2x squared plus 1 comma 5x and then plus 1, and g of x is given to be 5 plus 1 comma 5x. First of all, are these functions, or we can say more, these are polynomials as well? Are these polynomials? Both of them are polynomials. What is the degree of the first one? What is the degree of the second one? What is the constant term of the first one? The constant term? Which one is written in the standard form? The first one. So the first one is in the standard form. The second one is not the standard form. If you insist to write this in a standard form, how do you write it? 1 comma x plus 5. Yes? 1 comma 5 times x plus 5. Okay, so we want to solve the problem. So f of x is supposed to be equal to g of x. So this means that instead of f of x, I can put this expression is equal to 5 plus 1 comma 5x. Okay, so you can forget the problem here. You are facing a new problem. This new problem in mathematics is called an equation. What is the degree of this equation? Second degree. So it's a quadratic equation. For quadratic equation, the generic rule was to move everything to one side and then use ABC or PQ formula. But then we had some exceptions which will facilitate or make it more rapidly doing that, yes? So in this case, because this is coincidentally, this term and that term are the same, so in your head, if you move it to the left, what will happen? This would come cancel. Okay, so it means that even though it's a quadratic polynomial, it's a quadratic equation, but not the complete version, yes? So in principle, instead of moving 5 to the left, it is better to move 1 to the right. Okay, so then it becomes 2x squared, and then 5 minus 1 is 4, and then what I'm supposed to do now? You have to divide by 2, and then take a square root. So what should I be careful about? Is that correct?
No.
It's not complete, yes? What should I put? Plus or minus. So, for which values this equality holds? Two values. One of them plus square root of 2, the other one minus square root of 2. You see that the exercises are actually quite simple. Okay, so this is more or less at the level of the book. So let us explore a little bit more, not that much. Okay. Uh, of course, you have hopefully a little bit, you remember a little bit from the previous Math 2C course. We can add polynomials, we can multiply them, yes? We can subtract them. Now let me just try to ask you some questions. What do you think will happen for the degree of two polynomials if I multiply them? So in other words, I give you a polynomial, p of x. I give you another polynomial, q of x. Okay? If I say that I have a polynomial, definitely it has one degree, it has some degree, and this also has some degree. Do you agree, first of all, in your head, intuitively, if I multiply polynomials, the result is also a polynomial or not? Intuitively, I just want to talk intuitively. It's clear, yes? So the result is also a polynomial. For example, if I have, let me just also remind you, this is the topic of the next lesson, so I will talk about this later, but let us just do this. Okay, so it's a polynomial of degree 1, a polynomial of degree 3. If I multiply them, it takes a while, but it becomes a polynomial at the end. So it becomes x to the 4 plus 5x squared plus x plus 2x cubed plus 10x plus 2, and then it becomes x to the 4 plus 2x cubed plus 5x squared plus 11x plus 2. And if I ask you, do you agree that this is a polynomial? Hopefully you agree with me, yes, it is a polynomial. Okay, now do you find a generic rule for the degree of the product with the degree of each one of the polynomials individual? Do you want to answer, Asa? Okay. Anyone else? Intuitively, I just want you to just try to convince yourself this is the case. Yes?
You add the degrees.
They add the degrees. Yes? You see, why is that? Because when you see this is the first degree, it means that there is a highest value for the power in this one. There is a highest value for this in this one. And then it is clear one possibility is to multiply these two, which will give rise to x to the 4, and it is clear the rest of the terms cannot exceed that power. Yes, because you have chosen the highest power here, and you multiplied them. Yes, so the highest power become 4. So what can I say? I can say that if you multiply these polynomials, and then you ask about the degree, I can write something here for you. What can I write here? Degree of the first one plus degree of the second one. Okay? Okay, but now I want to ask the same question for addition of polynomials. What do you think will happen? Can I write a formula similar for the product, this time for the addition? Or what is your conjecture? Conjecture, by the way, in mathematics means a rough or educated guess that we still don't have the proof for it. Either you can prove it quickly or it takes centuries to be proven, yes? So what can I write? Can I write something in particular for this case? Yes, Ali? Yeah.
I think the highest degree, which one of them has the highest degree, that one will be the highest if you add them together.
Okay. How many of you agree with him? Yes, do you agree? So this becomes the highest. Yes. So you mean if I want to write it in mathematical language, what you are saying, if I understand you correctly, so you tell me that you calculate the degree of p of x or determine the degree of p of x. So determine the degree of q of x. And by the way, this is a standard in mathematics as well. And then you look at the maximum of these two numbers. And then you say that this is the case.
No, like,
And by the way, this is a well-defined notation in mathematics. So I have a number, I put them in curly brackets, it becomes a set, and I put a maximum. So it chooses the maximum of these numbers here. And then I put equality. Do you agree with this? Yes? Yes or no?
Yes.
100%? The answer is no. Because there are some exceptions. Yes? And then can you cook up an example for an exception for me? There are many exceptions, but you have been a little bit careless. So what happens that the coefficients of the highest degrees are symmetric, or opposite of each other. They will cancel out. And the degree goes lower. That's it, yes? That's it. That's the only exception that you need to understand. So if I give you p of x equals to, for example, 5x to the power of 3 plus 2x minus 1, what is the degree of this polynomial? 3. And I give you another polynomial q of x. It's minus 5x to the power of 2x plus 1. If I ask you add them, what will happen? These two, this is a coincidence, they cancel out, and then the answer becomes what? 3x just it. Okay, the degree is 3, but the degree of the sum is 1. But if you say what is the maximum, if I want to use this formula, then what should I write for this? I should write 3. What should I write for this? I should write 3. The maximum between these two numbers is again 3. So you are saying that the degree of the sum is 3, which is not right because the degree of the sum is how much? 1. So if I want to write, unfortunately, this is not 100% equal. But do you think what things can happen? So equality can happen. I agree with you. If this is minus 4 rather than minus 5, then when I add them, the degrees is still 3. So yes, you are right. Sometimes it becomes equal to the maximum. But in general, can it exceed the maximum? No, that is for sure. So it becomes equal, or if you are unlucky, it becomes less. So unfortunately, equality doesn't hold here. But this relation holds. So the degree of the sum is less than or equal to this one. And what do you think about the subtraction? That's the same story. Yes, the degree of the difference can also be like that. For example, if I change this to positive and subtract them this time, again these two will cancel, and this time this becomes x minus 2, and the degree is 1. So the degree of p of x plus or minus degree of q of x is this one. Yes? Okay, let me ask you one more question. If I have a polynomial and I raise it to some power, but natural power, 1, 2, 3, 4, etc. Do you believe that it still becomes a polynomial? Intuitively. Yeah, you take a polynomial, raise it to power 4. What does it mean? It means that you take that polynomial, write it, juxtapose it 4 times, multiply them. Yes? There is no reason that this is not a polynomial. Now I ask you, so what is the degree of that polynomial? I want you to be able to... This is extremely important. I don't know why they haven't talked even about these things, but it's important to know it. Yes, Rasmus?
Just the previous degree to power down.
No. A little bit... The previous degree not to power n. Times n.
Oh, yeah.
Yes? So this becomes n times the degree of p of x. Do you agree? Take a polynomial. First of all, I told you here, so let me just do it. If I want to take polynomial to power 3, for example, what does it mean? It means the degree of p of x multiplied by p of x multiplied by p of x. That's the meaning of p of x to power 3. But we just learned, if I multiply and then find the degree, I have to find the degree of each one of them and add them. But here, all of them are the same. So this becomes the degree of the first one, plus the degree of the second one, plus the degree of the third one. But all of them are the same. So I am adding the same number 3 times, so it becomes 3 times that number. Yes? Yeah? Yes?
Just ask, when we're writing this like degree annotation,
Mhm.
do you really have to include the x? Can we just like write degree of p? We're not really finding this function.
No, to polynomials, you should also talk. In a polynomial, you should also specify your variable.
But in this,
Yeah.
is why is that like important? It's just
Because in some other things you can discuss about two different spaces talking about polynomials on one variable versus another space on polynomials about the other variable. But you are right. If you want to specify a polynomial for a computer program, you just give the numbers. You even don't care about the variable. Yes.
Whether there are two variables or more.
No, if there are two variables, then you need to talk about the degree with respect to each variable individually. That's also a good question. I don't want to go through the details of those things. Because, for example, if I write a polynomial p of x and y, two variables, then I can write x to power 2, y to power 3. I can ask you, if I ask you what is the degree of the polynomial p, you should answer 5. Okay, you should add them. But if I ask you what is the degree of p with respect to x, you say 2. What is the degree of p with respect to y, you say 3. But if I just ask you what is the degree of this polynomial, you need to add them. So you need to find the degree of polynomial with respect to first variable, the degree of the polynomial with respect to the second variable, and add these two degrees, and that is by definition the degree of the whole polynomial. Yes? But let us not go through these things. But I think these are important, even though the book decided not to talk about degree in this way at all. But I just want you to know about these things. For example, it shouldn't be hard for you to immediately realize what is the degree of this polynomial. So if I write something like this, p of x is equal to 2 to the power of x2 plus 3x minus 1 to the power of 10 multiplied by 5x cubed plus 2 to the power of 7. And then I write plus 7x minus 5. First of all, I want you to develop this feeling that immediately under 5 seconds you realize that this is indeed a polynomial. Do you agree with me? Okay, now I can ask you what is the degree of this polynomial. I want you to have this intuition to be able to give me the answer in 2 or 3 seconds, because if you really want to expand this, okay, be my guest. You need to continue until May, okay? Or if you want to computer, by the way, we can also test it with GeoGebra to see how it works. It's, by the way, how many terms will be involved roughly? If you assume that you expand, but you don't simplify. Because if you simplify, of course, some terms will combine and the number of terms will reduce. But I mean, assume that you just expand and leave it like that. How many terms will be involved?
I mean, only the first one would be
3 to the power of 10. And this one would be 2 to the power 7, which is 128, and 3 to the power 10, God, I don't know in my head. And then you multiply them. So it is a very, very huge amount of work. But under 5 seconds, you should be able to tell me, according to these rules that you yourself actually helped me to write it down, you should be able to tell me what is the degree of this polynomial at the end. And I want you to be able to do that. What is the degree? You would say that if I ask you what is the degree of this one only, you know. What is that? 2. But I am raising a degree 2 polynomial to power 10. I know the rule. The degree of the powered one is that power times the degree of the polynomial. So if I ask you what is the degree of this part, what is your answer? 20 is the degree of this part. And if I ask you the same question, what is the degree of this part? 21. And now if I ask you what is the degree of this part?
420.
No, adding this time. Because the degree of the product is the sum of the degrees. Yes? So the degree becomes what? 41. Do you think this one matters? No, because if you have something to power 41, even if you are so unlucky that every term is cancelled, one term will survive, and that is x to power 41. So the degree of this polynomial is 41. This is what I really expect you to be able to do it quickly. And that's possible. Yes? Yes or no? Okay, let me give you a tricky question and then I can end. The tricky question is that if I go through this pain to expand this, I will get a polynomial. This polynomial will involve a lot of coefficients. Do you agree? Can you imagine it in your head? Are you with me or not? Yes? And then you add all those coefficients. Do you understand what's happening? You expand this one, a lot of terms, I don't know how many of them, 3 to power 10 times 2 to power 7, and then plus 2. And then you get a lot of terms with some coefficients. You pick up all the coefficients and add the coefficients. It becomes a number. Yes? My question, what that number is? Do you need me to repeat or not? Yeah. So you expand. It becomes a huge expression with a lot of coefficients. Take the coefficients. They are numbers. Add them. It becomes a number at the end. What that number is? Yes?
42.
I don't know. How did you calculate?
I just thought that.
No, it's a bit, I want you to understand. One of the coefficients, let me ask you one question. Another testing, I want to test your intuition again. Forget about this part. You told me the degree of this polynomial to power 10 is 20. You are. Can you tell me what is the coefficient of the leading term? No?
1024.
Yes, 1024, 2 to power 10. Because when you write this 10 times, so you see, answering some questions are relatively simple if you expand your intuition. Yes? So if I give you this and I ask you what is the leading term, you can immediately answer. Because the leading term means the term with the highest power. So if you want to generate the highest power, it is clear you take the highest power from here, you take the highest power from here, you take the highest power from here, and then multiply. And if you do that, it becomes 2 to the power, it's a square to the power of 10. Which is 2 to the power of 10, x to the power of 20. So it's 1024 x to the power of 20. So if I ask you this, if I give you this in the exam and ask you what is the leading term, you don't need calculator, you don't need computers, you can immediately answer this is the leading term. So for example, in this case you might need calculator. If I ask you what is the leading term, can you write it down for me? Don't calculate it. What is the leading term of this one only? 5 to power 7, x to power, no, 21. This is the leading term. Understandable? Okay. Now, can you tell me what is the leading term of the whole combination? What you have to do, you have to take the leading term here, multiply it by the leading term here. And of course, this doesn't matter here because this is just power 1. So the leading term, if you really want to write it down, is 2 to power 10 multiplied 5 to power 7 multiplied by x to power 41. So that's the leading term. Okay? Now, the question is harder now. So you have to be creative. My question is that This is one coefficient, only one out of many coefficients. Now you take this coefficient, which is actually a huge number, you take another coefficient, all coefficients, and then add the coefficients, it becomes one single number at the end. My question is what that number is. This is one of those questions that you need to be a little bit smart. Calculation is not involved here. Otherwise it will take for ages. Put it in a very simple context. Tell me, let us look at this. Let us look at this. This is the skill that you need to learn, by the way. This is a harder problem. Don't let this problem distract you. It's complicated, but no one forces you to think about that. You can construct some simple problem for yourself. So if I ask you what is the sum of the coefficients, you can immediately answer. What's the answer? Or can you? What is the 8? Yes? But what you did, you add them directly. Now try to find an alternative way which is not directly adding, but it's possible in that context as well. So you told me 2 plus 5 plus 1. This is the sum of these coefficients. Okay? So let me give it a name, P of x. Okay. Can you see what's happening? Yes?
Replace x with 0? Or have x as 0?
No,
What?
but you're very close. If I replace x with 0, the answer becomes 1. Replace with?
1.
1. And that's 1. So when I ask you to find the sum of the coefficients, it is P of 1. So you just need to calculate the whole expression, but replacing x with 1. Because if I have a polynomial, any polynomial, imagine it in your head, it's not hard. If you take x's away, and instead of x put 1, because 1 to any power is 1, and 1 multiplied by any number is the same number, you get the sum of the coefficients automatically. Is that right? So that's the same story. So I put 1 here to see if I can calculate it. But at least I have the number. 1, it's 2, plus 3, it's 5, 4, 4 to power 10. This is 7 to power 7. And then I have 7 minus 5 is 2. So that is your magic number. Okay? And I really want you to go and use GeoGebra, because in national exam, I told you I will arrange a way that you can use GeoGebra. So try to convince yourself that this is indeed the case. This will teach you a lot. Don't underestimate these exercises that I'm telling you. Do it with GeoGebra yourself. I think GeoGebra is capable of expanding it and then try to find a way to read the coefficients. If not, I don't know, if you know Python or something, you should be able to write a code to do this. I don't know if GeoGebra is capable of doing these things. I don't know how can you ask GeoGebra to give me the sum of the coefficients so that you can compare that number with the number we got here. But probably if you know coding, probably you can do that. Yes?
You could write P of 1 and then that expression.
No, of course, because yes, that is correct, but we want to use the GeoGebra to confirm that what we have done is correct. Of course, if I ask GeoGebra to calculate P of 1, it generates this one for sure. But it is not clear from this that this is exactly the sum of the coefficients. You understand what I mean? Because we want to find a way to confirm ourselves. Any questions? Okay, so I will end the lesson now. I don't know when the lesson ends. Do you know?
14:20.
Oh, just now?
Yeah.
Okay, I was trying to make it short, but it probably will happen next time. I will update the Google Classroom, which pages and which. So page 8, 9, and 10 are the pages in the book, and we will continue. Thank you very much.